Hello everyone. Let us look into this question. Evaluate integration of sine inverse under root of x by a plus x dx. So let us solve this question here. I is equal to integration of sine inverse under root of x by a plus x dx. Okay. So let x is equal to, I'll substitute as a tan square theta. So dx equal to 2a tan theta into internal derivative secant square theta d theta. And from the same case, x is equal to 8 tan square theta. From here, tan theta will be under root of x by a. Okay, so this becomes integration of sine inverse under root of a tan square theta by a plus a tan square theta into, in the place of dx I can write as 2a tan theta secant square theta d theta. So this will be under integration of sine inverse under root of a tan square theta by, if I take a common, it will be 1 plus tan square theta into 2a tan theta secant square theta d theta. So next step, sine inverse, okay, integration of sine inverse under root of a tan square theta by a into 1 plus tan square theta I can write as a secant square theta into 2a tan theta secant square theta d theta. So this simplification, that is a gets cancelled, and under root of tan square theta by secant square theta, the simplification is sin theta, right? We know this one. Sin square by cos square by 1 by cos square. This will be sin square theta, which is under root, becomes sin theta. So I can write it as sin inverse of sin theta into 2a tan theta secant square theta d theta, right? So this 2 gets cancelled. I will be left with only, so let us bring this 2a outside. I will be left with only theta into tan theta secant square theta d theta. So again, now we will convert this part in everything here. We'll assume that tan theta is equal to t. So when we do the derivation of this, secant square theta d theta is equal to dt. From the same condition, theta will be equal to tan inverse t. Now the above one becomes here as 2a integration of, in the place of theta I can write as tan inverse t into, in the place of tan theta I can write as t into secant square theta d theta. In the place of secant square theta d theta I can write as dt. So when I arrange them, this becomes 2a integration of t into tan inverse t dt. Okay. Now we will go with the further simplification of this. Here we can apply the formula of integration of f of x into g of x dx. This condition will apply it here. Now, when you have in this part, we know the condition clearly that f of x into g of x dx, that is integration of f of x into g of x dx, is equal to f of x into integration of g of x dx minus integration of derivative of f of x into integration of g of x dx whole dx, right? So we'll apply this formula here. In this case, tan inverse t and t we have here. So tan inverse t is f of x and t becomes g of x according to the condition of Eilert. So tan inverse t will be f of x and t becomes g of x. So here the complete next step will be that I can write it as integration of 2a integration of, okay. Now this step I have to write here, that is t into tan inverse t. I am writing the same step here. Now we will continue. This I will write it as 2a into, okay, this complete simplification we will write in this form. Tan inverse t into integration of t dt minus integration of derivation of tan inverse t, derivative of tan inverse t into integration of t dt whole dt. This is what we have. So this becomes 2a into tan inverse t into this will be t square by 2 minus integration of this and this part. When you go for the simplification, it will be 1 by 1 plus t square into t square by 2 dt, right? So this next step will be 2a into t square by 2 tan inverse t, okay, minus here I will bring it 1 by 2 outside. So 1 by 2 integration of t square by 1 plus t square dt. Here also I will do one adjustment. This t square I will write it, here I will add and subtract 1 here in the numerator. So this becomes 2a into t square by 2 tan inverse t minus 1 by 2 integration of 1 plus t square minus 1 by 1 plus t square dt. Okay, next step. This will be 2a into t square by 2 tan inverse t, this remains as it is, minus half into integration of, here when you check it in this part inside it will be, when I separate this I will get as, see here, 1 plus t square by 1 plus t square, they both gets cancelled. I will be left with only 1 minus 1 by 1 plus t square dt. This is what I will be left with. So next step, 2a into t square by 2 tan inverse t minus half into, this part will be integration of 1 dt minus integration of 1 by 1 plus t square dt. This is what I am left with. So this becomes 2a into t square by 2 tan inverse t minus half into, this is t minus tan inverse t, okay, plus c. So this is 2a into t square by 2 tan inverse t minus half t plus half tan inverse t plus c. Okay, this half I will take it out completely outside and this half will cancel with 2a. Okay, I will write this step. 2a into 1 by 2 t square tan inverse t minus t plus tan inverse t plus c. Okay, so this 2 and this 2 gets cancelled. So I am left with a into t square tan inverse t minus t plus tan inverse t plus c. Here I can take out tan inverse t common. So I will get it as a into, okay, if I take out tan inverse t common, I will be left with 1 plus t square tan inverse t, okay, minus t plus c. Now this is what we got up to here. We will substitute all the values in this case. Okay, so what was t we took? Our t was nothing but tan theta. Okay, so I will substitute in this. So this becomes 1 plus tan square theta, right, into tan inverse t minus t plus c. Okay, so we got it up to here. Now next step, when you got these conditions here, then the further simplification of this part will be, here wherever we have t, what was our t, will substitute those values as we substituted here. Here also will substitute it. So this becomes a into 1 plus tan square theta into tan inverse of tan theta minus tan theta plus c. Actually, here also we can substitute it. Just one, I took one step below for further simplification. So a into this is 1 plus tan square theta remains as it is into this 2 gets cancelled. I will be left with theta minus tan theta plus c. Okay. Now, if you check all the conditions, what was our tan theta and all these things from the beginning stage itself. So, let us take to the first part. Here, we can see here a tan square theta, we took it as x. So, from here tan theta is equal to, we got it as root under x by a, right? Here, I will write one step. Since x is equal to a tan square theta. This is what we have written here, right? So, and one more thing, from this part, a tan square theta, x is equal to a tan square theta. So, from here, what I got the next step is tan theta. Tan theta is equal to under root of x by a. This is one thing here, and also from this theta value also. So, theta also what we got from this case, it will be nothing but tan inverse of tan inverse. I'll write it clearly. Theta is equal to tan inverse root x by a. So this is what from the beginning stage. So finally, when I substitute all the conditions here, what I will get? So a into here in the place of this 1 plus in the place of tan square theta, I can write as x by a into in the place of theta, that is I can write it as tan inverse under root of x by a minus root of x by a plus c. So now if I want, I can take a inside and you can multiply this. So a into, I will get it as a plus x by a, right? This I have this one into tan inverse, right? So tan inverse under root of ax okay. So here we can do one thing. If we want, we can further simplify, we take out a common, or else we can easily simplify here itself, or else we can leave it here itself. So we can finally leave it part as a into 1 plus x by a into tan inverse x by a minus root of x by a plus c. I think this is better. Instead of going for the one more step and taking the a common, we can stop our solution here itself. The final solution will be a into 1 plus x by a into tan inverse of root x by a minus root x by a plus c. Okay, now this is the final solution. I hope you got the solution here. Thank you.